Hello everyone. In this video, we will see what is restoration. Now, before knowing the restoration, first we will know what is the difference between the image enhancement and the restoration. So here, first let us start with the image enhancement. Image enhancement, it is all about making an image look better, okay, and look better to the human eye. So we adjust the brightness, then increase the contrast, sharpen the edges, or we will boost the colors, whatever makes the image visually appealing in image enhancement. So because of this image enhancement, it is a subjective. Why? Because what looks good can be different for every person. Therefore, enhancement, that is image enhancement, is a subjective process in order to make the images look better. Now we will see what is image restoration. So image restoration, it is more scientific and it is objective. So it is a objective process in order to recover the original image. That is, here the goal is to recover the original image that was damaged due to blur, noise, motion, or other factors. So in order to do this, here we use a mathematical model or models and also the prior knowledge about how the image was degraded or how the image got degraded. For example, if the camera shook while taking a picture, we model that motion blur and apply the inverse to the to restore the image. Okay, so here uh, for enhancement, you have an example like contrast stretching, where it is a technique for which is used for image enhancement because it is based primarily on the pleasing aspects and it might present to the viewer, whereas removing the blur by restoration, here it is applying a deblurring function so that we get a restored image. Okay, so here contrast stretching is for image enhancement and removing the blur is for the restoration. So in short, we can say that enhancement makes an image look better, while the restoration, it will try to bring back what the image originally looked like. Okay, now next we will see a model of the image degradation or restoration process. So any degraded image, it can be modeled using a simple mathematical framework. Now here the image degradation model, it mainly consists of uh, two things. Okay, that is a degraded image, it is formed when the original image undergoes two things. What are those? It is a degradation function and a added noise. So first we will see what is a degradation function. Degradation function, it will represent like what caused the damage to the image. Okay, what was the reason to damage the image or what is the cause. So for example, like you have blur due to motion. Okay, the image has been blurred because due to the motion. Then it may be blur due to out of focus length, or it may be atmospheric disturbance in the satellite images. It can be camera shake or sensor malfunctioning. Okay, and in the model, this is considered a system that will distort the original image. Okay, so this degradation function, it will distort the original image. Then we will see the second thing, that is the added noise, nu. So noise is a random disturbance which is added to the image. Okay, so example for noise are sensor noise, short noise, you have electronic interference, then low light noise, and many more you have. Now if we consider this figure here, it shows the degradation process uh, which is modeled as a degradation function. This is the degradation function H, that together with the additive noise, that is nu. Okay, it operates on the input image f of xy in order to produce the degraded image, that is g of xy. Now given this g of x comma y, uh, some knowledge about the degradation function and some knowledge about the additive noise. Here the objective of the restoration is to obtain the estimate f cap of xy of the original image f of xy. Okay. Now we want to estimate this f cap of xy to be as close as possible to the original input image f of xy. Okay, so the more we have the knowledge about the degradation function h and the additive noise nu, the closer will be these two, that is f cap of xy and f of xy. So this part, it is the degradation part, and this part, it is the restoration part. Now if h is a linear position invariant process, then the degraded image, this is a degraded image, that is g of xy, it can be given by this equation. Okay, that is g of xy is equal to h of xy convolution f of xy plus nu of x comma y. Here h of x comma y, it is a spatial representation of the degradation function. And next, the convolution of the same, the convolution of in the spatial domain, it is analogous to the multiplication in the frequency domain. So this is in the spatial domain. Now we will convert this to the frequency domain. So here this equation it is converted to the frequency domain, that is equivalent frequency domain. We can write it as capital G of u comma v is equal to capital H of u comma v, f of u comma v plus n of u comma v, where these capital terms g, h and g, h, f and n, these are the Fourier transforms of the corresponding terms in this equation, that is this one, which is in the spatial domain. Okay, so this was about the restoration. Thank you. Sorry, one more thing I left here. One more thing is the goal of the image restoration. So the goal of the image restoration is to recover the original image f of xy from the degraded image, that is g of x comma y. And for this we must know, or we must have the knowledge about the degradation function. We must have the knowledge about the additive noise nu, and here it looks like the mathematical like tools like inverse filtering, Wiener filtering, then deconvolution. Okay, and here and also the restored image. Okay, the restored image, it is equal to the inverse of the degraded applied to g of x comma y. Okay, g of x comma y is what? It is a degraded image. So the restored image, that is f cap of xy, it will be the inverse of the degradation applied to g of x comma y. And also we can think this which will make this easy to understand, like you have a clean image f of xy. Okay, now something happens to that image. Suppose there will be some damage to that image because of the blur h and the noise, additive noise nu. So now what happens? This was a clean image. Now whatever clean image you were having, it has become a bad image now. What is a bad image? G of xy. Now this bad image we want to convert back to the clean image, but it cannot be done 100% back as that of f of xy. So this g of x comma y, it will be made as f cap of x comma y with the help of restoration. Okay, so this was about the restoration. I hope you have enjoyed the video. Thank you.